nucleophilic substitution reaction is very important chemical reaction in organic chemistry. Now, today I shall discuss about the SN reaction. SN means that nucleophilic substitution reaction, that is Rx. The electronegativity of X, that is halogen, and electronegativity of carbon is lower than halogen. That is, electronegativity of halogen is greater than carbon. This alkyl halide may be methyl halide, ethyl halide, or maybe methyl iodide, ethyl iodide. These are all alkyl halide. In the case of alkyl halide, the electronegativity power of halogen is greater than carbon, so that electron cloud of the sharing bonds, sharing electrons are shift towards halogen. So halogen develop partial negative and it will be carbocation. Then carbocation is attacked by nucleophilic substitution, nucleophilic reagent. Then the product will be RNU. Here positive and negative charge will be neutral. That is, carbocation and nucleophilic reagent, negative charge and positive charge will be neutralized. That is called SN reaction. SN reaction means that where any reactant, its group or atoms is released by nucleophilic reagent, this is called SN reaction. SN reaction are two types. One is SN1 and SN2. SN1 means that nucleophilic substitution of unimolecular substances, and SN2 is biomolecular nucleophilic substitution. That is, the substitution reaction happened in biomolecular compounds by nucleophilic reagent. That is called SN2 reaction. As for example here, if in the case of halogen, iodine, bromine, chlorine and fluorine, the bond strength of iodine is less than bromine and bromine is less than chlorine. So the releasing power of iodine is greater than bromine and bromine is greater than chlorine, chlorine is greater than fluorine. That is, iodide releasing power of iodide is greater than bromide, bromide is greater than chloride, chloride is greater than fluoride. That is, stability power of fluoride is greatest than iodine. That stability with alkyl halide, the stability of iodine is less than fluorine. So iodine will be released easily from alkyl halide. This is the mechanism of alkyl halide in the case of SN reaction. Now we shall consider it SN1. In the case of SN1, let us consider Rx. Here Rx first converted into carbocation, then X will be released here as halide, because the electron tendency, the electron of the sharing bond shift towards halogen, because the electronegativity power of halogen is greater than carbon, so that it will be converted into carbocation and it will be released here from halide. This is the step 1. This R, that is carbocation, will be attacked by nucleophilic reagent, then it will be an SN1 reaction, which is step 2. This is SN1 reaction. SN1 reaction happened in two types, two steps, but it is called SN1 because its rate of the reaction depend on the reactant, only, does not depend on the concentration of the nucleophilic concentration. So it is called SN1 reaction. As for example, let us consider 4 carbon, that is tertiary butyl bromide. At first it will be converted into tertiary bromide cation, then bromine here released as bromide. This tertiary carbocation attacked by tertiary carbocation attacked by nucleophilic reagent. Then it will be here positive and negative will be neutralized by nucleophilic substitution, nucleophilic reagent, that is SN1 reaction. If in the case of hydroxide, then it will be tertiary butanol. Its hydroxide come from sodium hydroxide, aqueous sodium hydroxide. This sodium is then bromide, sodium bromide. This is the SN1. This mechanism is the SN1 mechanism. In the case of SN1, the rate of the reaction 3 degree is greater than 2 degree. 2 degree is greater than 1 degree. 3 degree means that where carbon is attacked 3 carbon, 1 carbon is attacked with 3 carbon, that is 3 degree. When carbon is attacked by 2 carbon, 1 carbon is attacked by 2 carbon, then it is 2 degree alkyl halide. 2 degree alkyl halide and 1 degree, when carbon is attacked 1 carbon only, that is called 1 degree alkyl halide, 3 degree alkyl halide, 2 degree alkyl halide, 1 degree. 3 degree alkyl halide means that when 1 carbon attached with 3 carbon, 1 carbon attached with 2 carbon, 1 carbon attached with 1 carbon, that is called 3 degree, 2 degree and 1 degree alkyl halide. Now we shall discuss the mechanism of SN2 reaction. In the case of methyl bromide, nucleophilic reagent attacked at the back side of the carbon because here density of electron is lower than another methyl group if attached with the carbon, that is equal 1 degree. It is then converted into a transitional state. This is transition state, and it will be then if here hydroxide, then here will be hydroxide, and here will be, then it will be converted into methanol, or methyl, it will be methyl alcohol. Here rate of the reaction is 1 degree is greater than 2 degree, 2 degrees is greater than 3 degree. That is SN2 reaction is reverse of the SN1 reaction. Rate of the reaction is depend on faster will be primary alkyl halide, then 2 degree alkyl halide and 3 degree alkyl halide. 3 degree alkyl halide, rate of the reaction of 3 degree alkyl halide will be lowest in the case of SN2 reaction. And SN2 reaction is the reverse of SN1 reaction. Thanks for all.
Thank you.